Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 9H. Myself, Shashwat Mudi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15 December 2025 in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presenters, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9th minute, I will raise a very gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in a chat box. Just before we start a session, I would like to introduce you all to the chair of this session, Dr. Uma Patel. She is an associate professor at Vishwakarma Institute of Technology, Pune, India. With the total experience of 18 years, she serves in the Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning. Her academics and research expertise include cloud computing and software engineering, and she is dedicated to advancing learning and innovation in emerging computing technologies. Ma'am, welcome to the session. Would you like to share a quick opening remark with us?
Yeah, good afternoon and to one and all. Thank you for this invite, and I'm happy to be a part of this and would like to listen to all the new research work going on. For the participants, yeah, 10 minutes is the time given. What I would expect is at the beginning, just introduce what is the problem statement that you all are solving, and then you can start explaining about your abstract introduction. So that could be a quick summary of what you all have worked on, and then you can start with your PPT. That could be fine. That's all from me, and all the best to all of you.
Now, I would like to start the paper. Ranveen, paper title, An Exploratory Survey on Memora, a memory aid application for Alzheimer's patients.
Good afternoon, sir.
You may please begin with your presentation.
Yes.
Good afternoon, sir. Good afternoon, sir. I'm Sarvesh, and this is Raveen along with me. And we are here to give a presentation on Memora, which is basically a memory aid application for Alzheimer's disease. The co-authors of the project is Revati ma'am, and we are presenting on behalf of her. Over to the next page. So the outline page shows the list of all the topics we are going to, present upon. Next page, please. Introduction and motivation. Alzheimer's disease is a condition which affects over 55 million people worldwide. Its symptoms lead from memory loss, disorientation, and it leads to difficulties in maintaining daily routines. These challenges not only impact the patient's ability to live their life in their own terms independently, but also lead to significant stress on the people who's taking care of them, or the caregivers. Memory aid, therefore, we propose Memora, which is a memory aid application. It is a mobile-based solution to address all of the challenges that the patients face holistically. Our key features include daily reminders to assist the patients with routines, along with location tracking, which we implemented by making use of geofencing technology to prevent the patient from wandering from their homes and other safe spots. Additionally, we also have a feature, which is the main feature of our application, that is AI-based. That is AI-based reminiscence therapy. This is used to stimulate memory and boost the confidence of the patients. All of these features collectively is used to improve the quality of life of the patient whilst maintaining the cognitive engagement. All of these provides the caregivers ample resources to take care of the patients. Next slide. An application has 5 key objectives. The first thing is to keep the interface as patient-friendly as possible to minimize the cognitive load upon the patient who's using the application. Secondly, our objective is to provide the application with daily reminders to support the patient to make him do routine activities like taking medications, uh, appointments, etc. To ensure the patient safety, our app makes use of geofencing technology. And then the app also provides a personalized reminiscence therapy, as I mentioned before, where memory cues are adaptively displayed to keep the patient engaged and boost their memory. Finally, we got a mood tracker to monitor the emotional well-being of the patient. Over to the next slide. We reviewed several existing applications relevant to Alzheimer's and dementia care. Firstly, we have Alzheimer's Master. This application focuses mainly on recording user interactions and gauging its engagement levels. While it supports interaction, it lacks practical day-to-day assistance and does not include safety or caregiver-oriented features. Next, we have OTM, which includes location tracking mechanism to track the patient's whereabouts. Although it improves the safety of the patient, it functions largely as a tracking tool and does not address cognitive stimulation or the emotional well-being of the patient. Thirdly, we have My House of Memories. It emphasizes more on the reminiscence therapy part of the treatment. However, the content is mostly passive and there is no personalization or adaptation based on the patient responses. Finally, there is MindMate. It offers cognitive games and exercises targeted for mental engagement of the patient. It is beneficial for stimulation, but it still does not provide real life assistance such as reminders, safety mechanisms, or emotional monitoring that the other applications provide. From this comparative analysis, we observe that the existing solutions address isolated needs, but none provides an integrated adaptive system, which led us to Memora. Over to Raveen, who will be giving a thorough description of the working of our project. Next slide.
Am I audible?
Yes, you are.
Okay. So, uh, okay, Memora provides a mobile-based assistive application which helps with the patient's daily routines and also the medication. And also it provides a safety ensuring system which tracks the location, which is enabled by geofencing technology. And additionally, we have implemented an AI-driven system which analyzes patient's response to these prompts and by which memories they have recognized frequently, we will try to display those prompts and also gradually reducing the ones they didn't. This gradually reduces the risk of emotional stress. Additionally, we have also built in a mood tracker, which further supports emotional monitoring by allowing the patient to record the daily feelings through an emoji-based scale, which is done on a weekly basis by the caregivers. And what we are trying to propose is we are trying to propose and we are trying to propose all of the features integrated into a single model along with quality of life features. Let's see the technology stack. We are going to prepare the app with the help of Flutter, which acts as the base platform of our project. It is used for both front end and back end of the application, and it also focuses primarily on the responsive and patient-friendly user interfaces. Like for example, we are trying to reduce the number of text in the application and increasing the number of images, which helps in navigating for the dementia patients. And for the data collection, we are following a hybrid approach where certain data are stored with SQLite and others are synced with Firebase via internet connection. Like, for example, the mood tracker data, which is sent to the caregiver on a weekly basis. Next, For the location tracking, we are using telephonic package Google Maps API. Is used for determining the location of patient. Google Maps API is used for setting the safe zone for the patient. And for the location tracking, we are using the patient's smartphone's inbuilt GPS. And the telephony package ensures the SMS alert is sent to the caregiver if there is a breach detection out of the safe zone. For TensorFlow Lite, this is used for the reminiscence therapy. This uses Q learning algorithm, which analyzes patient response and adapts accordingly to it. Okay. As for the methodology, for adaptive resonance therapy, what happens is, first of all, the photos and videos are uploaded by the caregiver from Firebase, and then the patient responses are observed carefully, and the responses which are most familiar and positively remembered are categorized and are displayed accordingly. For task reminder system, we have a severity level preliminary questionnaire, which is used to assess the patient severity level. These patient severity level are characterized into mild and moderate. The task creation is handled by the patient solely for mild level, and for moderate, the caregivers are done. Then individual reminders can also be set. For location tracking, as I have said, we have used geofencing. Patient movement is continuously monitored using GPS, the inbuilt GPS. Upon breach detection, with the help of telephony API, we will send the SMS alert. And for the mood tracker, the collected mood data is collected on a weekly basis to generate emotional well-being reports. Okay. This system design follows a MVC architecture, and we have two end users, patient and caregiver, and there is view layer, controller, and model layer. In the view layer, we have the login interface, reminder interface, and memory interface. The login interface comprises of patient and caregiver dashboard, each with its own working and functionality. And as per the controller, it handles input given by the interfaces, and it does the service in the backend and display the end results in the respective interfaces. Like for example, the daily reminders displays the end result at the reminder interface as a, and then the data are read and retrieved from the database, which is Firebase or SQLite, and the data is fed by the patient and the caregiver based on the functionality. So conclusion. So Memora is made to make the life easier and safer for patients while also offering caregiver reassurance and peace of mind. With the help of Flutter, we can provide patient-friendly user interfaces to make them navigate much easily. And SQLite ensures reliable backend infrastructure. This allows proper data flow between the caregiver and the patient. And it also follows adaptive module personalizes memory prompts, helping patients recall their memory. So, in conclusion, we can say that Memora provides both structure and safety to patients' everyday routine, allowing them to and also providing quality of life features. These are the screenshots of our current project. The first picture is the severity assessment question preliminary. The second is the task reminder system, and the third is reminiscence therapy. For now, we have implemented it without a feature. And these are the references that we have put. These are the prior works which is used for assessing and treating dementia care patients. This helped us understand the problem domain and see visibility in solutions. Thank you.
Yeah. Thank you
Thank you
for the
for
nice
the
present. Yeah. Yes, sir.
thank you for the presentation. Ma'am, do you have any
Thank
questions?
you, sir.
Yes, yes. Yeah, it was a nice presentation, but I would like to understand, like you were talking about geofencing and geolocation to track the patients, right? So
Yes.
what I need to understand is you all are doing it with the help of the patient's mobile?
Okay. Yes,
No, I'm
ma'am.
asking, yeah.
For
Okay, so
location
if,
tracking, we are using the patient's smartphone inbuilt GPS, which can function in offline mode also.
yeah, but then having said if he has Alzheimer's or something like a dementia and he has not carried his mobile, then how do you track patients in this case?
Ma'am, for this app to function, the mobile should always be with them. There is that one measure that we have to take in order to any application to work. So I think mobile should always be with them.
No, but then having said he's having the Alzheimer's disease, right? It might not be that he might remember it all the time to carry. And in case like he goes out and then without his mobile, then there's no possibility that you can trace him. That's one thing that y'all can work on. Like how can you without the mobile, then how can you track him or
Yes.
something like that? Can look at for the future work. Another thing is about the suggestion is for the literature survey, the table that you have put, you have named some apps, and then no, yeah, if you could go back, that would, yeah,
Yes,
this
ma'am.
one. So you have mentioned about the apps that are there and what they are working on. So
Yes,
this basically you need to put IEEE papers and the author name and then what they have worked on, rather
Oh,
than just a few names.
okay.
Apart from that, I think then what is the role of the caregiver in your work?
Okay, caregiver main role in this application is to there is this thing called reminiscence therapy where the patient's memories are uh, displayed to them so that they
Hmm.
can recall. What caregiver does is that from their end they can upload these memories in photo or video formats in the
And
database. Yes,
yeah, so what is the type of database that you have used or are
uh,
you?
in Firebase
So you're not
because it
using
works
any.
well with Flutter. That's why.
Okay. You're not using cloud or anything.
No, ma'am. For now, we have not seen it.
Okay.
We just focus on the core functionality. There's still much improvement in the future.
Okay. Okay. Thank you. That's it from my side.
Thank you.
So next we have Advay, paper titled Analysis of Indian Monsoon using Arctic Sea Ice Dynamics using Machine Learning.
Good afternoon. Am I audible?
Yes, you are. You may please present your
Yes.
presentation.
All right. Mm, just give me a second. I'm still trying to. Okay. That does not seem to be working.
What's the paper ID for this one, sir?
1276, ma'am. Is it all right if I quit and rejoin the meeting? There seems to be a problem with my Zoom on my end. Is that all right?
Okay, do it fast.
Yes. All right. Is my screen visible?
Yes, you may please begin.
All right. Okay, I hope this is visible, right? Analysis of Indian monsoon using Arctic sea ice dynamics using machine learning.
Yes.
All right. Good afternoon, everyone. My name is Advay Shinde, and I'll be presenting my paper on the analysis of Indian monsoon using sea ice, Arctic sea ice dynamics, using machine learning, right? So, the motivation and introduction for this is that the Indian summer monsoon is one of the most critical components of the Earth's ecosystem, as well as the climate system, and it directly influences around 1.4 to 1.7 billion people. That is almost 1/7 of the entire Earth's population, right? And the water security, livelihoods, agriculture, agricultural industries, and a lot of economies at scale as well. So, despite decades of research in this area, achieving reliable seasonal forecasts at lead times of 2 or 3 months seems a little difficult currently, and that remains a persistent challenge, right? So this difficulty arises primarily from the monsoon's highly non-linear, non-deterministic nature and its interaction across multiple spatial and temporal scales. So the traditional forecasting approaches have largely relied on sea surface temperatures and atmospheric circulation indices. And while these methods have obviously demonstrated some success, their entire predictive skill often degrades at longer lead times and also limiting their practical usefulness for early decision making, right? So considering the fact that Indian monsoon already supplies 75 to 80% of India's annual rainfall, something like a low skill issue or a circulation indices or traditional seasonal forecasts, which do not show um, which do not show high accuracy at 2 to 3 lead times, results in catastrophic failure to predict the Indian monsoon, right? So existing monsoon polar studies also rely mostly on linear statistical methods, and most of them use statistical methods and do not dive into machine learning methods, which was our first research gap that we identified, right? And also in parallel, the Arctic region in itself has also undergone unprecedented changes over the past few decades. And also these changes by themselves were rapidly declining changes. In the sense rapidly declining in the sea ice extent, right? So there are many emerging studies that we have referenced for our paper that these Arctic changes may influence tropic climate systems through large-scale atmospheric teleconnections, right? And much of the existing literature, the current literature, relies on linear statistical frameworks with limited exploration of, again, machine learning techniques. And so we were motivated by these gaps. And this particular study explores whether the Arctic Sea based features, the Arctic features such as mean precipitation, sea ice thickness, and sea ice concentration, when combined with multiple machine learning approaches, if they can contribute to improved understanding of the monsoon variability. So for this particular paper, we are our main focus was exploratory and co and comparative in nature, and we were not essentially aiming at producing an operational forecasting system, but it was more of a predictive and a potential relevance feature. So in the following sections, I will also discuss more about the data sets that have been used, our system architecture, our reference methodologies, and the rationale behind our model selections and the results that we have obtained, right? And the key limitations as well as the future directions for this particular research. Right. So moving on to the research objectives. The main objective of our research was to investigate one, the teleconnections between Arctic climate indicators, sea surface temperatures, and their lagged influence on the Indian monsoon prediction, as well as the Indian monsoon precipitation, and to identify the most influential the climate indicators and the temporal relationships contributing to monsoon precipitation variability through through feature importance and casualty analysis, and to also develop and evaluate a suite of machine learning models like random forest, XGBoost, for robust prediction of Indian monsoon and its anomalies. Right. So moving on to system architecture. Let us start with the most initial model that we used, that we also observed that most of the forecasting sessions and stations as well as analytics use, which is a linear regression, which is the baseline model, right? And we had aimed to use this as a benchmark model for us. And it also helps in quantifying the added value of machine learning models that we have also used later, which is gradient boosting, XGBoost, and random forest. But unfortunately, what we found out was the linear regression models often return a negative R2 score. Now, a negative R2 score means that the model is underperforming, and underperforming as compared to just taking out the mean of those values. So we were not able to proceed with with a study for the linear regression models, but then that prompted us to actually go for the non-linear models such as XGBoost and random forest, right? So moving on to random forest, and why did we go for random forest? So random forest captures non-linear relationships with a strong parametric assumptions. They are robust to noise and multi-collinearity in climate datasets. Also, prompted us to use random forest, because random forest essentially removes all of the unnecessary noise and leaves you with a data set that is absolutely clean. It also handles limited sampling sizes better than deep learning models, and it also provides feature importance, which helps in physical interpretability. So we essentially got more stable predictions across different data splits, and ensemble averaging also reduced overfitting that we were facing, right? And then moving on to gradient boosting models, we specifically used GBM XGBoost model, which was designed to capture weak but systematic signals in the data set. The sequential learning focuses on correcting the previous errors, and also performs well on structured climate and geographical data sets. So we also noticed that most of the parameters in the datasets have uneven importance, which is also why we went for XGBoost, right? So in combination, XGBoost reduces bias and random forest reduces variance, right? So yes. Okay, right. So now moving on to our datasets, the temporal framework that we took was 43 years, which is 1981 to 2024. We have the precipitation data, which is so the precipitation data, which is the mean precipitation in millimeters, which is what we got from the climate hazards group infrared precipitation with station data, which is a CHIRPS data set that we acquired from the Google Earth engine. Then regarding the Arctic sea ice variables, we got the monthly Arctic sea ice thickness, which is the mean SIT Arctic, and the mean SIC Arctic, which is the monthly sea ice concentration from biomass and NSIDC. And for the oceanographic predictors, we had established monsoon influencing regions, which were the Arabian Sea, Bay of Bengal, Caribbean Sea, Nino 3.4, and the interpolation data, which were obtained from the optimum interpolation sea surface temperature dataset. Okay, yeah. So methodology used. So the data sources first we collected.
You have 1 minute to conclude.
Yes. I'll be concluding in a minute. So we collected the data sets, pre-processed them, feature engineered model selection, as I'd covered in the previous slide. Then the validation strategies we used were the R2 score as well as the mean R square, as well as and then we also had the interpretability techniques like sharp and permutation importance. Okay. Results and analysis. The model performance that we had were tree-based models. The supporting evidence was that the R2 score was 0.1256, which is better than just removing the mean, which is better than concluding on the mean. And the RMSE score, which is the root mean squared error, is 12.14. And all of the linear models had negative R2 values. Feature importance, Arctic conditions and long-term trends are the most critical predictors supporting seasonal memory theory. And the winter ice thickness for the 3-month average is the top predictor. So the mean sea ice thickness and mean sea ice concentration from Arctic were the top predictors for 6-month as well as 12-month trend. So again, these are our references that we had used. We had used around 19 references for this particular paper. And the first four were the most influential for this. Thank you. Can I stop presenting now?
Yeah. Thank you for your presentation. Ma'am, do you have any question?
Yeah, Advay, you were talking about precipitation and weather forecasting. Is it only Indian rains or any other Asian countries? What is it that you're focusing on?
Ma'am, so we are essentially focusing on the Indian monsoon series.
Okay,
The Indian monsoon series.
so
Yeah.
okay, then you were talking like in your slide, you had in the results and analysis, you had R square value. What do
Yes.
you mean by R square value?
So ma'am, the R square value is essentially the value that you get or the performative value that you get, which describes whether your model is performing better than just removing or than just concluding the mean. Is it performing worse or is it performing best better? So for the linear models that we had used, the R2 value that we got was negative, which essentially meant that it was not as good, not even as good as just concluding the mean for those particular data set. The R2 value that we got for our rest of the models like XGBoost and Random Forest were positive R2 values, which ranged from 0.12 to 0.13, which essentially meant that the R2 values by themselves were the mean values by themselves were not
What's
as
the formula to calculate R2?
um
What do you need to calculate R2?
so ma'am, R2 value essentially represents variance in the data set. So what you need is an essential on the R2 value formula. I think we had referenced it in the slides as well. I'll just show the slides.
You also had skill score there, right? As a parameter to show the analysis. So what do you mean by skill score?
Ma'am, we had RMSE score, which is the root mean squared error score.
What is that error about?
So ma'am, the RMSE score essentially focuses on the error that was generated, essentially the noise that was in the data set, and how much noise was the particular model picking up on.
To work on that R square, did you have literature survey in your paper?
Yes, ma'am, we had literature survey. I'll just go
Okay.
over the literature survey as well.
No, that's okay, but please work on those fundamentals, because when
Okay,
you
okay.
talk about results and analysis, and there are so many formulas used for that. So what are the parameters required to calculate R square, and why is it used? You should be aware. Why only R square? Why not something else? Okay? So work on
Right.
that. Okay? That's it from my side. Thank you.
All right, ma'am, I'll work on it. Yes. Okay. Thank you, ma'am.
So next we have Shatendra Gupta, paper titled Anomaly Detection in Manufacturing Using Classical and Quantum AI.
Uh, Good afternoon to all the panel members and attendees. I hope I am audible and my video is visible. Can anyone confirm, please?
Yes, you are.
Okay, so I'm just sharing my slides. So I hope my slide is visible now.
Yes, your PPT was visible. You may please proceed.
What's the
Yeah, so
paper ID?
anomaly detection paper ID, ma'am.
Yeah.
I need to check. Let me give me a second, please.
That's okay. You can continue. I'll get it. Okay. You should actually put the paper ID in the slide. That's fine. Please continue.
Okay, so I'm Satyam Gupta. I'm working with the CDAC Hyderabad, and basically I used to work in artificial intelligence field, but now as quantum computing was booming, so we are slightly moving to the quantum machine learning paradigm. So here I will start with my paper title: Anomaly Detection in Manufacturing Using Classical and Quantum AI. So basically, we are our objective in this paper is to target the any defects in the production unit set up in the country, any kinds of defect in the products. So here, I'll start with why it is not moving. Okay, so the agenda for my PPT is like detect defects in the manufacturing items, and then we'll go through the literature survey that we have done, and then we'll go through our architectures. We tried the both architecture, classical and hybrid approach. Then we'll try to explain about the training and evaluation matrices. So the before I start the our work, I would like to do the introduction about the quantum computing and quantum revolution that is happening very recent in 2025 only. So it is basically a new paradigm where we are not using any classical gates like any classical gates where we represent the data in 0 and 1. Here we are using the qubits as a basic unit. Those are the logical gates, and those values are not lies in either 0 or 1. It is the state of the data is in between 0 to 1. The core mechanics of this quantum computing is like superposition, entanglement, and interferences. So we'll go through these three topics. Now here, why defect detection is needed in the manufacturing setup, just to ensure the quality of the product, where any small scratches, any pinhole, any kinds of product that is developed in the country or outside the country, we need to measure the standard of the product. For that, we need to find where the developed product is having that quality or not. If any defects or any anomaly is there in the product, that we can recognize, and then we can bifurcate the actual QC clear product and anomaly product. And also we can reduce the waste in the production unit, because if you know we are getting the anomaly, anomaly can be happen because of the machinery failure or any setup failures. So if we know that anomaly is happening, any defect is happening in the product, immediately we can go through the setup and we can find out the reason behind it, and then we can reduce the waste materials. Okay, to avoid faulty items reaching customers, that is very important, because it depends upon the customer satisfaction, when it individual is the customer only. So for that we need to work on this. We need to always provide the better quality product to the customers. And the final one is like manual checking is slow, because if we consider as like medicine production or any thin film production, so it's very difficult to find the defects in those things. It's like pinhole kinds of defect. We cannot see it naked eye. So in that case, we can use the AI or quantum AI kinds of a setup where we can identify these defects. There are some literature survey we have done. So in top level, these all literature survey have used the classical data. These are the classical literature survey, and they have majorly used the unsupervised learning. So here, why in anomaly, basically all these papers have given the more details about the unsupervised learning algorithm, because to find the anomaly, we don't know what kinds of anomaly will happen in the setup. It's a very unpredictable task. So if we have one kinds of data, we can train algorithm with that, and any deviation is from that particular data will be considered as the anomaly. These are some quantum hybrid architectures survey, where we have seen the setups they have given given in the before giving the data to the approaches to the algorithm, and also they have addressed some temporal features also, and also they have used this quantum supervector machines for some drug discovery kinds of things. So we have gone through this literature survey, and then we have then we develop our approach. These are the data set we have considered. This one, the very first one is NBTech data set. That is the benchmark data set, and it is open source. It is available for the anomaly detection now. It is having almost 17 class, like bottle anomaly, leather, and some other like pills and all anomaly. They have different kinds of categories. So we have also developed. We have also created our own data set, custom data set. This is a very thin, almost in tail micro, the thin film of aluminum and zinc. So where we have just tried to replicate the NBTech open source data set, like the way they have found the anomalies in there. They have created the anomaly data. We created in the same fashion, and that we have also annotated this data using some open source tool like CVAT and MakeSense AI. for training purpose. So our approach is actually the patch-based approach. So we are not using the complete image at once. We are just creating the small local safety field that we are using because we do not want to miss any small anomalies or small defect in the product. So here patches will help in the focus on each small area and capture the local defects. So it means we are not only using the local only, we are using both local and global safety fields. So this is our classical approach where we have a training data set like this, and we have a pre-trained feature extractor model that is a ResNet 50 we have used. And after getting the feature vector, we are passing this feature vector to the our model, that is Canon approach model, and where we are creating the patches here in this memory bank, and then we are processing it. So these patches are depends on like we are creating like 4x4, 8x8. It depends like what kinds of approach will work for us. So we tried multiple. We'll explain in the coming slides. So here, like seeing this block diagram, here input image we are giving, then we are dividing into the patches, then feature restriction like backbone we are using ResNet 50, and then we are again using a feature aggregator that will again collect the feature, and then we use a we create the like input dimension feature vector, and then we'll give our Canon model, and then Canon model will give us the final result that will map to the image as heat map. So these are some classical approach result. So these are small pinholes. So we are able to detect it with our model, and we are also able to localize the defects. So this is pinhole, this is simply scratch, and this is water bubble. Similarly, we tested our custom data, and we got the similar result, and we are able to localize it clearly. Now this.
You have 1 minute to conclude your presentation.
Okay. Okay, sir. So here is our core model, quantum hybrid model. So here we have introduced two circuits in this architecture. You can see in this architecture we have introduced two circuits: quantum layer 1, quantum layer 2. So these circuits look like this. So this is a circuit, we call it VPC, like a original quantum circuit, or NSATs we call it. So here we have some hyperparameter like image size 256 by 256, then patch size 16, and we trained for the 20 epochs. So these were again the quantum circuit. We tried different qubit circuit. So here I would like to explain this circuit. So here we have three stages in this quantum circuit. The classical data is coming from the feature extractor. Then we are mapping that classical data into our qubit quantum space. So we have taken here 4 qubits. Suppose if my circuit is a 4 qubit, so I can map 2 to the power 4 classical features. That means 16 classical features will map in qubit, and then this first unitary matrix, this is called as a rotational gate, a single qubit rotational gate. It will map the data into qubit. It will like rotate this single qubit, and then it will propagate through this second layer. Where in second layer also we are using a RJ gate. That is the here we are doing the entanglement. So
I think there is a disturbance. No, it's not. You're not. Shashwat, is it that only I'm facing it?
Ma'am, I think it's a network issue.
Okay, but you're able to hear it clearly?
No, ma'am.
Okay.
Anyone can confirm, please?
Now it's okay.
Okay, wait. So I'm audible now?
Yeah. Please continue.
So these are the test cases, test samples of our hybrid model. So these are the data. This is the later MBTech data where we have tested, and we are able to like find the defects, and we are able to localize it. Similarly, we train on our custom data, and if we are able to test on this, and we can localize our custom data also. So these are the experiment results. So we can see here a slightly like our quantum approach is slightly better than the classical. So here we have used multiple qubit circuits. So these all details like we have given here in matrices. These are the future works, like speed of the real-time factor uses, because quantum is a very heavy processing task. Quantum computer is a very heavy processing task. Now to handle the new unseen defects, if any like different defects are there rather than the usuals, and to integrate some IoT kinds of devices to streamline the production unit. Thank you for myself.
Thank you for the presentation. Ma'am, do you have any question?
Yeah. Now, can you go to their results? This you were talking about 4 qubit and all 8 qubit, 12 qubit. Yeah, here. Yeah. No, the last but one.
Yes,
Okay. So you mean to say if you use more qubit, is it I mean like better, or how is that? What is your analysis on using? Just telling me the circuit is a 4 qubit, 6 qubit, 8 qubit, all fine. But which is a better one here?
Using the more numbers of qubit will give us the more high dimensional feature vector. So that will help us. But in quantum case, it can also reduce the accuracy because lots of interference will be there. Because
so you mean if it is 4 qubit, the I mean the images or the features are more or something like that? Or to my I just need to understand why these different qubits are there.
yeah, so suppose my 10 qubit habit circuit will process almost 1024 feature vector at one time.
Yeah,
So
now I got it.
yes, so aggregate result will be like better, but in case of again, if you go to the 50 qubit or 100 qubit, maybe interference will be there, and that can cause the degradation in the accuracy.
Okay, you talked about MVTech AD data set, right? So it's about the industry data set, I assume. And then what type of a product is that? I mean, like what type of a data set is belonging to which product in the industry? Because industry, when you say it is quite huge, right? So is it a metal or is it some wooden product, or what is that when you say industrial data set?
Yes, so MBTech actually having almost 17 classes, madam. So they're all classes in having 1,000 sample of good images and 1,000 sample of the defect images. Okay. And defect are like different kinds of defect. Like in case of leather, we have cut, color, glue, but in case of bottle, we have crack.
Yeah. So what are you working on? Is my question to you is what are you working on? Is it a leather or something?
Actually, this is unsupervised approach. So in this case, apart from the good images, we are using only good images for the training purpose. So apart from good images, all other things are like anomaly for us. So we are not categorizing in the detection where it is cut or color. We are simply giving the anomaly.
You're talking about only leather is what my question. I don't think you understood my question. So you're talking about detection of this on what product? Like, is it a leather or is it something else, or is it a metal that you're trying to put, or is it a cloth? What is that?
Our objective is to detect anomaly in the zinc aluminum film, this custom data that we have created. So we use this aluminum film for the building the capacitor, actually, industrial capacitors.
Okay, fine. You also talked about reducing waste and cost in your earlier slide, why you need this detection. So how do you reduce the waste? I mean, like when you detect an anomaly, usually it's already done, right?
Yes.
And that's a wastage and already cost has incurred. So why did you write to reduce waste and cost?
Okay, so ma'am, actually, in production unit like this capacitor unit, capacitor building unit, they have almost 10,000 meter rolls. So suppose if we got the anomaly in early, you detect the anomaly in early stage, we can stop the machine and then we can figure out the cause of the defect. And
but then the defect will be already, I mean, like quality check will be done when that leather, okay, let's take a roll of leather, and when the roll of leather is got from the client or usually the quality check is already done, right?
the setup of the industry is first they are doing some coating on the film, then they are going for the slitting of the film, then they are going for the like production. Here we are putting this solution in the coating itself, where we can get this defect, we can detect this
Okay, so
defect.
I understand from your thing is that during the processing, there will be some defects,
Yes, yes.
and that is what you're trying to detect. Yeah, fine
Yes.
with me. Yeah, thank you so much. Yeah.
Thank you.
So now next we have Ishan, paper titled Efficient Hyperparameter Tuning in Federated Learning System using Meta Learning.
Hello. Am I audible?
Yes, you are. You may please begin with your presentation.
Yes. I'll just share my screen. Can somebody please confirm if it is visible or not?
Yes, it is visible. You may please start.
Okay, I have also entered the slideshow mode. Is it still visible? I am changing the slides right now.
Yes, it is.
Okay, so am I audible? Hello.
Yes.
Hello.
Yes, you are audible.
Okay. So, good evening to everyone and to the panel. I am Ishan Saha from the Department of. Today, I will be presenting our work titled Efficient Hyperparameter Tuning in Federated Learning Systems using Meta Learning. And this work has been co-authored by alongside with Vidit Singh and Dr. Malvinder Singh Balli. And the paper ID is 1345. So, federated learning enables multiple clients to collaboratively train a shared model while keeping data local, which is essential for privacy sensitive applications. However, federated learning performance is highly sensitive to hyperparameters. They include hyperparameters are such as learning rate, batch size, and local epochs on which the model runs. So in the real world deployments, client data often non-IIT, meaning different clients have different data distributions over there. So this significantly degrades our model training and efficiency. So this is our abstract. And the problem statement over here is that we address the static hyperparameter settings which in federated learning systems fail to adapt to non-IED data and heterogeneous client data, leading to a slow convergence, unstable training, and high communication overhead, especially for CNN-based image models. So now, here are our objectives. First, to design an adaptive hyperparameter tuning framework for federated learning. Second, to improve convergence and stability for CNN-based image classification for non-ID data. And third, to reduce communication overhead while preserving privacy and scalability. So these are the research gaps which we had. So from the existing literature survey, we observed that the prior work focused on personalization or just discussed, but they were generally static and they did not change much. So this and focusing on meta learning, so it lacked round wise adaptive tuning mechanisms. So after each round of training, the mechanism was not changing the parameters. So here are 5 references which I have quoted: Tan et al., Zhao et al., Wang et al., Ryan et al., and Kundru and Kim 2023. So here is our proposed framework. So this slide contains the framework which we have proposed in our paper. Each client trains a CNN model locally on its private image dataset, and only model updates with the central server which we have. The server aggregates, the server aggregates and updates using a federated averaging method, and it employs a meta learning module, which it is present over there, which analyzes the training behavior and patterns such as loss trends and convergence stability. So convergence is basically when a model achieves a certain level of accuracy and its improvement is not as significant as it was there. So earlier, if it went from a 60% to a 75%, now it only goes from 75 to 75.1 or 75.2% accuracy. So based on this feedback, the system dynamically updates hyperparameters for next communication round, which enables efficient training. So now I would like to discuss the dataset which we primarily used and the pre-processing techniques. So the dataset was the MNIST balanced dataset. So it was taken from the TensorFlow. It is in the TensorFlow federated datasets available. So since this data set is highly available through the use of TensorFlow federated, it can be initialized in the clients very easily. So yes, so MNIST balanced dataset contains grayscale handwritten characters, and the data is pre-collected and locally stored in a non-IID manner. Then we also have standard computer vision processing, which is applied at the client side, which includes image resizing and pixel normalization techniques and encoding into labels. So the raw image data never leaves the client and it stays with them. So that ensures that there is a particular privacy maintained. So we do not get this particular update at the server. The server only gets the updated parameters. So now coming on to the algorithms, models, and softwares which we have used. So the model is CNN, which is a convolutional neural network, and this was used for the handwritten image classification. Now onto the federated aggregation. Uh, we used the federated averaging model. So it locally aggregated the model and updates to the global model. Then we have the meta learning based hyperparameter tuning, which dynamically adapts the learning rate, batch size, and low polypox on the training behavior. Now, for the software tools, as I already mentioned, TensorFlow federated. This was used to implement the federated learning framework. And for the CNN model development, we used TensorFlow. We also used Keras, but we were getting a better response with TensorFlow. And this all was done on Python. So there, why our system separates us from the what separates us and why are we better over here? How is our approach better? We differ from existing methods by performing some things such as adaptive meta learning based tuning instead of the static configuration which is done in the prior works which I have stated. It also our system also stabilizes training under non-IID data, converges faster with fewer communication rounds done, and reduces overall communication cost which is performed. This also we also did with CNN based image classification techniques, so it ensures relevance is there in the computer vision application. So our results over here. So we had a 27% faster convergence compared to the Fed average model and 6.4% improvement in classification accuracy, close to 30% reduction in the communication overhead costs, and a stable detail. We had a stable training on the non-ID data, and this basically improved good resource utilization. So now to conclude our presentation, so the framework which we have proposed, demonstrated faster convergence for CNN-based image classification techniques which were done. It also reduced the communication overhead, which is essential in non-ID client settings. We also preserved privacy, which was one key issue which clients faced, because according to them, if they are using any model, they contact to the global server, which according to them, which is actually true, which leads them to believe that the data is being sent outside. So all the data stays local. We only get through our framework, we only get the uh, hyperparameter settings and nothing else. So this work is currently under progress, and the future plan would be to increase this for a large scale federated deployment, because currently it was tested on local systems over here and not on high number of federated systems. And we would also want to extend it to different data modalities and explore other energy efficient training methods for edge devices. These were some references which we have used. These are only five. We have 25 plus references quoted in our paper. And the baseline for all the comparisons which we have done is the second paper, the Zhao et al. Paper, Federated Hyperparameter Tuning. So that set a generalized framework for using the Fed average model. So, yeah, thank you so much. I am open to questions.
Thank you for your presentation. Ma'am, do you have any
Yeah.
questions?
Yeah. Ishan, this is for you and your project mates who are working on this. A very simple question is, what's the difference between the traditional machine learning training and your federated learning?
Okay, so thank you for the question, ma'am. So traditional machine learning training and federated learning. So in our federated learning, it is a very decentralized. So model training is not happening at one centralized server. It is distributed among different clients who are using that particular service. So the data, whatever is trained on your device, stays on your device until and unless needed. So that is what happens in a federated learning model. And everything you do on your system is decentralized. So it does not contact the server regarding your data. Whereas in
Yeah.
certain machine learning models, the data may be transferred to the server over here. And certain machine learning models, they lack the capability to store high amounts of data.
That is fine. What you said is like, but then if they are doing the training on different systems, they should be integrated also, right?
Uh, could you, ma'am, actually, I did not get you
You
properly.
said federated learning is decentralized, and then on every machine the training is happening, right?
Yes,
Locally
ma'am.
on your machine. But in
Yes,
the
ma'am.
end, everything has to be integrated, right?
Yes, ma'am.
Yeah, it has to be. Otherwise, what is the use? Like you're doing training on one machine separately, and then together you don't integrate and then come up. Okay, so there is some integration part there. I think you missed out on that. Secondly, I also wanted to understand why CNN and why not others in your handwriting classification. There are other algorithms as well, right? Like
So
KNN and
you
SVM
want
and all.
to.
Why not that?
So,
Did
ma'am,
you?
CNN's established higher. Yes, ma'am.
No, the others are also good, right? So did you try with SVM and probably your results would have been better? Did you try like that using different
So,
classifications?
yes, ma'am. Yes, ma'am. We actually tried with KNNs over here, and also we have not explored SVMs currently. We want to
Okay.
first establish the generalized CNN route. Then we would
Mhm.
be further exploring into if SVMs were more better in this. KNNs did
Yeah.
not perform as well because there was no instance-based segmentation happening over there.
You can try, so that you be better able to produce your results saying that CNN also could be used, but this was the accuracy and then KNN was better, something like that to prove your point that why only CNN when others are there. Fine.
Yes, ma'am. Yes, ma'am.
Yeah. Yeah. Thank you.
Thank you so much, ma'am. Thank you to the panel.
So next we have Shravani, paper titled Fam Health, a comprehensive family health management system.
Good afternoon, ma'am. Am I audible?
Yes, you are audible.
Okay, I'll start the screen sharing. Is the screen visible?
Yes, you may please start the presentation.
Okay, good afternoon, everyone. My name is Shravani Desai, and I'll be presenting FAM Health, a family-centric digital health management system. This work addresses a key limitation in existing mHealth application, mobile health applications. Their focus on individual users, which often leads to reactive healthcare, background and problem definition. Most existing digital health applications are designed for individual users. Health data is fragmented across platforms, leading to reactive healthcare behavior. Family level collaboration and shared accountability are largely absent, which directly affects long term engagement and preventive care. Health outcomes are strongly influenced by family behavior and shared environments. However, existing digital systems fail to leverage this. This motivated us to design a collaborative and preventive digital healthcare platform that encourages shared responsibility. System objectives are FAM Health is proposed as a family-centric digital health management platform focused on preventive care. It integrates health tracking, reminders, intelligent assistance, and gamification while maintaining privacy and offline usability. Proposed system overview. FAM Health is family-centric digital health management platform designed to support preventive healthcare rather than reactive treatment, combines health tracking, reminders, and intelligent assistance, uses shared family dashboards for collaborative monitoring, integrates gamification to sustain long-term engagement. The key system modules include medication and appointment reminder system, nutrition logging with offline food dataset support, AI assistant for symptom-based non-diagnostic guidance, family profile management and shared dashboards, gamified leaderboard, and activity tracking. This is the workflow and architecture overview. FAM Health follows a modular workflow design. It uses authentication and family setup from the system entry point. Health data is processed locally before the intelligent assessment. Rule-based health risk assessment ensures transparency. Retrieval-based AI assistant provides non-diagnostic guidance. Gamified leaderboard promotes sustained engagement. Healthcare applications require safe and explainable intelligence. Black box predictive models increase ethical and legal risk. FAM Health uses rule-based assessment for transparent decisions. Retrieval-based AI provides non-diagnostic evidence-based guidance. On-device processing preserves user privacy. Health risk assessment module. The health risk assessment module evaluates lifestyle parameters such as BMI, diet, and activity levels. It computes an interpretable risk score and classifies users into low, medium, or high risk categories, enabling preventive guidance without diagnosis. Gamification and engagement. Gamification plays a key role in sustaining engagement. Family leaderboards and shared challenges promote accountability, resulting in an observed engagement rate of appropriately 85%. Compared to existing mobile health applications, FAM Health shifts from individual tracking to family-centric collaborations. Offline intelligence and gamified engagement addresses usability and accessibility gaps present in current systems. Average application load time of 1.8 seconds. Authentication success rate 99.3% using Firebase authentication. Health risk assessment achieved 92.5% accuracy during evaluation. Overall user satisfaction rate of 90% based on usability testing. These are some screenshots of the mobile health application. Here we can add reminders for appointment or any medicine. And also I have a nutrition analysis of what we had for breakfast, lunch, or dinner. Then this is the health risk assessment module, which uses retrieval based augmentation for calculating the score. It also pop-ups the health warning if the score is below 50, and also gives recommendations for healthy lifestyle. FAML demonstrates the effectiveness of family-centric preventive healthcare. This system integrates explainable intelligence, gamification, and real-time synchronization. Evaluation results indicate strong performance and user acceptance. The proposed design is scalable and deployment ready. Future enhancements include wearable integration, telehealth support, and advanced analytics. These are some references which we used. Thank you, ma'am.
Thank you for your presentation. Ma'am, do you have any
Yeah.
questions?
Yes. Literature survey you completely missed on, I think.
Literature survey, we actually just uh, analyze from the original applications that are available in the market, so which are generally
Yeah,
mostly
which one?
individual
Like you analyzed it, but they didn't put it in the paper is what I'm talking about in the presentation. That's one thing. Okay. And second thing, why gamification here?
So gamification, the idea which I wanted to display is that if we have our family, and then gamification leads to encouragement for healthy lifestyle. So as
What
shared
do you
in
mean by
the
like what have you included in gamification? What do you mean by that?
as you can see, I have included normal tasks like hydration, then steps, then meditation, and good night sleep. So such basic challenges are there for maintaining healthy lifestyle.
Okay. Okay. And what do you mean by explainable intelligence?
Sorry.
What do you mean by explainable intelligence?
The AI, which it is not predictive. It is based on a knowledge based data set. So it just matches the results from the data set and gives the answer. So it is not diagnosing anything.
No, it is basically explaining the users about how, why, everything. That is, it's explaining everything. That's why it is called explainable AI. Okay. So please read on that when you're putting words there. You need to understand what is explainable AI. That's again huge domain there. Okay.
Okay,
And
ma'am.
please
Thank
do
you.
include literature surveys and then nowhere. And what about these data? Where is it stored? Is it stored in the app?
It's stored locally in JSON file, and data set for like it is used in nutrition, like nutrition data, and the knowledge for the AI assistant.
No,
For that only we
if
have
I
used
am the
data set.
patient, if I am the patient, my demographics are stored. My name, my age, my diseases, my medications. Where is it? Where is it stored? Is what I'm asking.
We have used Firebase for authentication and data.
What about the security of that data?
Firebase ensures security of the data.
Yeah, just check on that. Okay. Thank you.
Okay. Thank you.
So next we have Aryan Singh, paper titled harnessing artificial intelligence to measure the effectiveness of adaptive learning models.
Good afternoon, ma'am. Am I audible?
Yes, you are audible. You may please be- begin with your presentation.
Okay, so is my slide audible, visible? I am sharing my slide.
Yes, it is.
So good afternoon, everyone. My name is Aryan Singh. I am from SRM Institute of Science and Technology from the it is located in Delhi NCR campus. Today, I will be presenting my work, my paper titled "Harnessing the Artificial Intelligence to Measure the Effectiveness of Adaptive Learning Model." The paper ID is 1208. I am one of the co-authors as well as a presenter for this paper. So let us start with the introduction. So education institutions today they generate a large amount of the student data, but they often lack effective system to use this data for early intervention. So most students are identified as at risk only after a midterm or final exam, which is already too late. Now, when we are talking about at risk student, we are talking about like the problem they face, like depression, anxiety, or some other mental problem it can be. So currently, the model that are available, they usually analyze these students on the basis of their scores, like midterm scores or the final scores. So what we are going to do is we are going to build a model that is not going to use the grades, because by the time we analyze the grade, it is already very much late. So to provide timely help is very much difficult. So we are not going to analyze the student on the basis of their grade. We are going to analyze them on the other factors like their presence in the classroom, their presence in the internet, how much they are present in the circular activities. So all these factors will help us to identify whether the student is at risk or not. So here's a literature review of our work. Like we have used four papers for this PPT, and when it comes to main paper, we have around 19 more papers. So when we have gone through the most of the research paper, the common limitation that we were found were that most of the model were focused on overall accuracy, and they were mostly black box model, and they were not explainable. Like why they were not explainable, like why they are coming to the conclusion that that this student is facing a risk. And when we now coming to a model that we have proposed, we are proposing a hybrid ensemble model. So what we have did is we are taking first the two model, random forest and gradient boosted. So we are taking random forest because it is a very high stability model, and it can also handle the outliers very well. Now coming to the gradient boosting, it can we are using the gradient boosting because it can automatically learn the correct the weakness and correct it for the sequential errors. Now, after these two models, we will be selecting the top predictive features like we have discussed: attendance, their logs in the classrooms, their internet time, their free time, their extracurricular activity that they use. And after all these things, we are going to apply the plat scaling so that we can get the calibrated probabilities for the reliability. Now, the final prediction generated by the logistic prediction blender that learns optimal weights. So what we are going to do is, after the calibrating probability, the input will be passed to the logistic regression, so that it will be able to provide the output through the ensemble modeling. So the main advantage that we got is that it is going to be very lightweight, it will be easy to deploy, and it will be able to balance the performance between accuracy, precision, F1, and other matrices. Now coming to the methodology one. So first we are collecting the data. We have combined the UCI math plus Portuguese data sets. And then we did some pre-processing, like we have encoded the categorical columns, remove duplicates, and handle the missing values. Then we did some mutual information, like we have selected an important feature. So all the features will be selected except for the grading grades, like the final grades or midterm grades. And then we will train the model, like we will train the random forest and gradient boosted, like taking 100 tree and 100 estimator. And initial gap depth is going to be 3. After that, the probability calibration will be there, like applying the plat scale into both RF and GB to get a certain outputs for the logistic regression method. Now here the experimental setup that we have used. So most of the point we have already discussed, but coming to the environment one, we are going to use a Python scikit-learn and Google anti-gravity. So basically we are using Google anti-gravity because it's a new version, it's a new environment from the Google, because and it is more of a AI friendly. Now coming to result and analysis. So we have compared uh, random forest, gradient boosting, hybrid ensemble model on all evaluation matrices like accuracy, precision, F1 score, and AUROC. Now for the hybrid model, we have achieved highest recall, which is 96.3. which is very critical for identifying at-risk student. And best we have got the best F1 score, which is 87.2%, which is very much balanced, which is balancing our precision and recall. Now coming to the highest AURC, we have 73.56%, which is the best probability discrimination. Now RF and GB are individually performed very well. But when it comes to hybrid and stability, delivering the most balanced overall performance. Now here are the matrices that we have used. Coming to, we can see that the accuracy, recall, F1 and AUROC are giving the highest matrices. But when it comes to precision, we are having slightly less. We have slightly less precision for as compared to random forest and gradient boosting, because when we are combining the hybrid, when we are using hybrid ensemble model, we are getting more of a false positive methods, false positive elements. And here's the performance comparison of all the matrices that we have used in a bar graph form. Now conclusion. So we have a hybrid random forest and gradient boosting ensemble model that is providing a balanced and reliable approach for student approach prediction. We have a feature selection probability calibration, which significantly improves our prediction consistency and interpretability. And the model achieves a strong result with high recall, which is 96.3% and competitive F1 and AUROC. We have removed the grading system like midterm and the final grades for the early academic intervention. And the lightweight design ensure that the model is very much practical for the real world employment in the educational system. And here are the references that we have used. And thank you very much.
Yeah.
Thank you for the presentation. Ma'am, do you have any question?
Yes. Aryan, you talked about accuracy being 96.8, right?
Yes,
96.3, sorry. So, how about the previous ones? Like, what was, if you look at the literature survey, do you think yours is the best, or there are some algorithms that are much better than yours?
ma'am, the thing is, we are not only talking about the accuracy, because if we look into the previous works, they were only talking about the overall accuracy. But the thing that we are doing here, we are talking about accuracy, precision, recall, and F1. So that we are providing a more of a white box type model. We are telling the institute how we are analyzing the student properly.
So does that all matter when you're talking about, because if all that mattered, then already previous people also would have worked on that, right?
Yes, ma'am. Ma'am, I think in current scenario it should matter, because nowadays the health of students are very much related to it, because in the student in the college and the school we are very much pressure to do many things. So it is becoming a big big of an issue. Because in the previous it might not be in a big issue.
So how are you going to validate your work? Are you going to try on somebody, or what? Who is going to tell yours is better, your work is better? Are you
Actually, ma'am,
going to do experimental analysis, or what is that you're going to do?
so ma'am, initially we have taken the UCI data set, which is collected from various institutes. And after we are in the future, when we build a dashboard, we might approach some universities for the data sets.
Okay. So there is no medical field people involved in this.
Ma'am, currently no. They will be more in the later stages when we get our final data set from the colleges and all the schools.
Okay. Okay. Thank you.
So thank you, ma'am.
So next we have Sangeeta. Paper title, Machine Learning Classifier for Pregnancy Risk Prediction with Identification of Optimal Algorithm, Type and Key Maternal Characteristics using maternal and obstetric database. Sangeeta, are you there?
I think she's in mute. I don't know.
Let me check now. I think she is not there. Okay. Now we have Preeti Mai. Paper title, Optimized Detection of Infected Traffic in Industrial IoT using Cross Database Validation.
Am I audible?
Yes, you are audible. You may please
Let
begin with your presentation.
me share my screen. Is it visible?
Yes, it is.
Okay, thank Okay, a very good evening to all. My name is Pritimai Satpathy from Department of Computer Science and Application, Chitkal University, Bhubaneswar. My research title is Optimized Detection of Infected Traffic in Industrial IoT using Cross-Dataset Validation. This is my presentation outline. Next is now I will discuss introduction and background of my paper. Nowadays, IoT is used in each and every field, starting from healthcare to industry. And the use of IoT in industrial automation and control system is known as IoT, Industrial Internet of Things. It is expected that IoT have a market value of cover 1.46 billion US by 2028 and also 50 billion IoT devices to be used in industrial by 2030. So cyber security for IoT system is very much essential as IoT networks are produced heterogeneous data. So like traditional security methods like firewall and antivirus might not efficient to tackle all the type of IoT data attacks. Um, IoT IoT devices are often resource constrained and produce heterogeneous data that are require uh, pre-processing before analysis. Uh, in machine learning also used in IDS system to build the predictive model at an early stage. Uh, in our research, we basically focused on cross dataset evaluation, where we improve the IoT intrusion detection, where IDS trained on one environment and performs also well on different environments. Our research goal is to develop an optimized machine learning based IDS for IIoT that can accurately detect malicious traffic in different environments, for which we basically use the feature selection method genetic algorithm as a worker based feature selection method. In our experiment, we use multiple machine learning algorithm like general linear algorithm, machine learning algorithm like stochastic gradient descent, Gaussian events, all also include the several boosting assembly algorithm like light gradient boosting, extreme gradient boosting, histogram gradient boosting. And we compare all the performance of the algorithm in using two recent IoT dataset which we will discuss in the upcoming section. For cross dataset generalization, we perform correlation alignment and compare the performance also using the transfer learning. This is the literature review we have done. Here we include only the 7 literature, and in the paper we have included more than 30 plus paper of the recent papers. Based on the literature review we have done, we found that in most of the cases, cross data set generalization is overlooked. So we include in our paper so that ideas perform in also perform in different environment also. This is the proposed approach of our methodology. First, we select the IoT dataset, then we do basic B processing, then apply the genetic algorithm as a feature selection method to find the most significant features. And then we apply the different machine learning algorithm from classical machine learning algorithm to boosting algorithm like extreme gradient boosting, light gradient boosting, and adaptive gradient boosting. Then hyperparameter tuning of all these algorithms like we increase the learning rate of XGBoost and light gradient boosting, and also add the regularization in stochastic gradient boosting. Then we do the cross data generalization. Our main focus is on cross data generalization, where we train on one data set and test on another data. Then we and perform the same using train on different data set and test on another data set. And finally, the model prediction based on the cross data evaluation. The data set we used in our paper is the mostly use two data sets. One is WSTL IoT 2021 and another is X IIoT IDS dataset. The first dataset, which is a real-life testbed dataset, contains 41 features, in which generally the attack traffic is very less. So we apply SMOD to balancing the dataset. The WS IoT dataset contains 4 specific attacks, that is DOS, Regions, Common Injection, and Backdoor attack. And the recent dataset, whose name is XIoT, which contains 421.417 normal traffic and 399.417 attack traffic with 65 features, excluding the labels. It contains 18 attack variants and also include modern IoT protocols and attacks, which are absent in the older dataset. So you choose this newer dataset. For data pre-processing, you utilize the Python built-in package pandas and NumPy frameworks in the pre-processing step. We remove the unnecessary features in both the dataset, like start time, last time, source address, destination address, and IP address and ports in both the dataset. Then we'll handling the missing values for each of the dataset by filling. First, we find out the missing values with more than 500. Then we input the missing address with the median of that feature. Then we do the label encoding for categorical feature. And train test field is not given in the dataset, so we will do manually using stratified sampling. By 80% of the 80% of data we will use for we have used for training, and 20% we have used for testing. For imbalance handling, we applied SMOD on the training set. For normalizing the data, we have used min-max scaling. Next slide. Next we use genetic algorithm for feature selection. We use genetic algorithms to select the most significant and optimal and find out the most optimal feature set from both the data sets. In our each genetic algorithm chromosome is encoded as a binary string of length equal to the number of features. 1 bit indicates the feature at that position is selected, while the 0 means the feature is excluded. Each chromosome fitness is evaluated by training a given classifier using only the selected feature. The genetic algorithm was run for 50 generations with a population size of 10 in our experiment analysis. In each generation, 4 parents were selected to produce 6 offspring via crossover. For implementation, we have used the PyGuard GA library. And lastly, we found that less relevant features were dropped by the genetic algorithm. Next slide. We have basically used multiple machine learning algorithms in the two data sets. We used Socratic gradient descent, Gaussian neighbors and boosting based algorithm like adaptive boosting, extreme gradient boosting, and light gradient boosting, histogram gradient boosting. We found that the general machine learning algorithm like stochastic gradient boosting and the Gaussian Nebbins also perform well with hyperparameter tuning. These are the performance metrics we have used, like accuracy, which is calculated by using the true positive plus true negative divided by the true positive plus true negative plus false positive plus false negative, where we define true positive when an IDS identifies sinner as an attack and means that a real attack has been found, and it's false positive, which is the confusion matrix when an instance is identified by the IDS that it is attack, but it has been confirmed to be normal attack. And true negative, where the IDS recognize that it is usual. Additional study revealed that the occurrence is normal. And false negative, some cases were misclassified by IDS as malicious attack, whereas they were later confirmed would be normal occurrence. We also measure the training time, testing time, and learning curve between the training score and the cross validation for using 10-fold cross validation. Next slide.
You have 1 minute to conclude your presentation.
Okay. I will come. within 1 minute. This is the experiment result we got from the WUSL IIoT 2021 dataset. Here we found that SGD for the training time and the time of STG is very less, and the perform well with only 11 features out of 41 features in from the WST IoT dataset. This is the experimental result we got from the XIoT dataset. Here also we found the light gradient boosting and SGD perform well in XIoT dataset. And this is the learning curve. This is the learning curve of the stochastic gradient descent and Gaussian Naive model using 10 for cross validation. To avoid overshooting, we have used elastic net regularization with hyperparameter value of alpha 0.001 and L1 ratio 0.15 in case of STD. We use the hyperparameter value variable smoothing e to the power 0 in the case of GNV. The blue lines here this shows the training set, and the red line here shows the cross validation score. In case of HTG, as the sample size increases, the training score stabilizes at 40,000 samples, and the cross validation score stabilizes with the rising amount of data. In both the cases, there is small gap between the training set and the cross validation set, which shows that both the algorithms perform. We will also learning curve of all the algorithms in your experimental analysis but here where you add only the HCT and GNV learning curve. Next slide. This is the main result of our analysis. There is a cross data generalization research where we train on the XIoT data and test on the W. Here we use only two. We have used only two classifiers. That's the STG and the light gradient boosting, because STG is very much performance using low training time, and the light gradient boosting perform well in both the cases of the data set. Here we compare using baseline, that is without any transfer learning. Also we apply choral adoption in both the data sets. And in case of when we training on the XIoT data set and the test on WUST IoT data set, using the choral adoption, the accuracy is 95.28% and the precision is 83.39%. Which shows that our model also perform well on different environments. Now we conclude our paper. We present an optimized intrusion detection framework for IoT that combines both genetic algorithm as a Warper-based feature selection, data balancing, and machine learning. Our proposal significantly improves the detection in cyber attack in industrial environment. The successful cross data evaluation in our experimental analysis shows that our model also perform well on different environments. Using simple machine learning models with smart reprocessing, our model perform very well than the complex deep learning models. For future work, we add hybrid deep learning model on the selected features to further improve the detection and ensure that explainability of the features. Also, we add in the upcoming future work. We also in the future work, we use federated learning approach where models train on different IoT sites without sharing raw data, and additional dataset and attacks we also plan to include in our future work, where we extend the framework to detect not just network intrusion but also device level anomalies. This is the reference we have followed. Thank you.
Thank you for the presentation. Ma'am, do you have
Yeah.
any questions?
Yeah. Now, in your presentation, you mentioned that your data set had around it detects around 4 types of attacks, and you told one of them was common ejection. Can you explain more on that? What do you mean by that?
Actually, ma'am, we have taken two widely used IDS dataset. One is WSL IoT dataset and one is XIoT dataset. In WSL IoT dataset, there are 4 attacks in the dataset. The author has already given, but in XIoT dataset, there are 18 variant of attacks. When we evaluate the cross dataset generalization, we found that when you train on XIoT dataset, as it contains more variety of attacks, the training will then the accuracy we have got
No.
is 95.
I'm not talking about accuracy and all. I'm talking about you have told about attacks and your work is on detecting the attacks, right, in the industrial IoT. So
Yes,
when
ma'am.
you are putting different type of attack, what do you mean by command injection, no? Or backdoor attacks? What do you mean by that? You should be knowing about the defects, right? When you are detecting it, should be knowing about it.
Yes, ma'am.
So you don't have any idea about it.
Actually,
Okay, fine. You should know about it. You're talking about
and
attacks in the industry using industrial IoT, and then you don't know what are the different types of attacks, right? Should make a thorough study. What are those attacks and why only these I am addressing in my work, right? So you should know about all of it.
Okay.
Okay.
Okay,
Yeah.
thanks, ma'am.
Thank you.
Hello.
So next we have Manish Jaiswal, paper title Robust Cycle Slip Detection in NAV IC Signals using Differentiate Geometry Free Combination with Adaptive Thresholding. Manish, are you there?
Good evening to all of you. And am I audible?
Yes, you are audible. You may please begin with your presentation.
Okay. Good evening to session chair, ma'am, and all everyone present in this presentation. My name is Manish Jaiswal, and I am working as a junior research fellow and research scholar in Graphic Era, deemed to be University Dehradun, under the project sponsored by Space Application Center, Indian Space Research Organization, Ahmedabad. And this work is also a part of that project, and the title is as Robust Cycle Slip Detection in Navik and signal using difference geometry free combination with adaptive thresholding. And my paper ID is 1357. So, starting the presentation, I would like to tell you that how the content will go forward. First, I will explain the cycle slip and what is cycle slip, the reason behind that, and what is the importance of cycle slip to detect and to correct it. Then I will show you the receiver setup. Then I will take some minute to show the motivation behind the difference geometry free based cycle slip detection. Then I will tell synthetic cycle slip injection strategy, and then result and discussions and conclusion. So uh, this project is basically about the navigation and to find out the correct position of a user using the satellite communication. So when we receive the signal from the satellites, we have different parameters that we have to analyze, out of which one is the cycle slip. That is basically an event inside the parameter. So cycle slip is the sudden discontinuity in the carrier phase measurement in the GNSS and NAVIC signals. Basically, it is NAVIC, navigation for Indian constellation. It is Indian developed navigation satellite system. So a sudden jump in the measured carrier phase by an integer number of cycles basically uh, distorts our user position. So mathematically, if I talk about what is carrier phase observation, so it is represented by phi t, and that is the combination of rho t plus c delta tr minus delta ts. This is basically timing constraint. Then plus it is basically the ionospheric delay. Then we have P of t, that is tropospheric delay, lambda is the wavelength, and n is the integer ambiguity, and epsilon is the noise. Basically, what happens when the signal travels from satellite to the earth and to the user, it travels through the different layers of the earth, and the signal crosses each and every layer, and each and every layer gives some contribution in that signal. So, in the case of carrier phase signal, we have to find out what is the sudden jumps, where is the sudden discontinuity. So here we have given a figure. That figure is showing that the blue line is basically a phase and red one is a cone. Basically, in the received data, we find four different parameters. One is the phase measurement. Second is the pseudo range. third is the Doppler data, and fourth is the C by N naught, that is carrier to noise ratio. So in the case of carrier phase measurement, we generally get this sudden jumps. These jumps are known as cycle slip, but these are not present in the code range, right? So code range is not having any sudden jumps, but these are having noisy. And whereas the phase is having this jump, but these are very precise. So in order to get a precise position of a user, we need to use this phase measurement by removing this cycle slip. So what are the possible reasons for cycle slip? So this includes a lot of reasons. One is the signal blockage. That means if between the user and satellite there is no line of sight, uh, signal gets blockage due to trees, buildings, human body obstruction, railway platforms, overhead structures, etc. So the slip may happen. Second is low signal strength. By any mean, if the carrier to noise ratio is less than a threshold, then also the cycle slip may happen. Then the high dynamics, that means if we are traveling in a train, aircraft, and vehicles in sudden acceleration and deceleration, there may be some cases of cycle slips. Then next is the receiver issue. We have a receiver, right? That receiver basically receives the signal from the satellite, and it is having its own structure, its own block diagram, its own methodology. If there is any discrepancy in the receiver, so there may be a case of cycle slip that includes the PLL loss of clock reset, and temperature effects also. And next is the severe ionospheric scintillations, right? So if ionosphere is basically a upper part of the Earth atmosphere, so if there is a rapid variation, that can cause phase fluctuations, and it is very common in Navik L5 and S1 signals. So next is the importance of cycle slip detection. What is going to happen if we not doing this detection, or we are doing this detection? So in the case if without detection we are using the carrier phase, that is becoming physically meaningless, because the integer ambiguity is corrupts the signal. Or in other way, we can say that the carrier phase continuity breaks due to the cycles. But when we detect it and repair it, the carrier phase continuity restores and high accuracy of positioning is preserved. So this is the receiver setup. This receiver is basically installed at Graphicera University campus. In the figure, you can see that here left part is an antenna, that is outdoor unit, and second image is basically for the indoor unit. So there are two different receivers. Which are connected to the particular setup, and this is basically the data capturing screenshots, that how it looks like, the data is logging or not. So we receive the data in two different files that are the RINEX file format. RINEX is basically stands for receiver independent navigation exchange data, and we have two different files. One is the navigation data, second is the observation data. So basically, observation data includes the four different parameters that I told earlier, that it it gives us the carrier to noise ratio, and pseudo range, carrier phase, uh, and similarly, the navigation data gives us the ephemeris. Navigation data basically includes where the satellite is, what are the correction parameters that satellite transmits to the user in order to get its position. So what is the motivation behind using DGF based? DGF is basically difference geometry free based cycle slip detection. As in the previous slide, I have shown that the carrier phase is basically having these kind of things. That means it also affected by the ionosphere, it is also affected by the troposphere, it is also affected by the uh, basically it is TS is for the satellite clock error. This is the receiver clock error. So these are the error, these are the factors that influence the performance of carrier phase. So in order to remove these, the geometry and clock terms making abrupt phase discontinuities clearly observable is dual frequency NAVX signal. Second is the geometry independent and robust, because this combination is geometry independent. How it is geometry independent? When we difference the two consecutive measurements, these parameters gets cancelled out. Third is the adaptive threshold. It handles real data variability, because the really collected data and the bookish data is entirely different, and these observations basically all about to detect the anomalies. That means if in the book we see a simple straight line and then a jump, then a smooth carrier phase, but in practical it doesn't happen. It always comes with a scintillation. So in this algorithm can also detect the adaptive threshold that handles the real data variability. Similarly, efficient for real time and embedded systems, and effective under the ionospheric disturbances. This can also detect the cycle slip in the case of varying ionospheric disturbance conditions. So in this part, synthetic cycle slip injection strategy, we tried to cover all the scenarios that may happen. So here I have given a table. So approach is basically a measurement. In our case, we log the data for per second. So it is
You have
1800
1
seconds.
minute to conclude your
Okay, okay,
presentation.
okay, 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 okay. It is 1800 second, it is 3600 second, it is 5400 seconds. So we basically have a dual frequency receiver. So we have a L5 frequency and we have a S1 frequency. So at approach 1800, we given the +1 and +1 cycle slips. So same integers, same slip on both frequencies. Similarly, same multiple slip, both frequencies, then opposite direction slip, then L5 only slip, then S1 only slip, and different combinations that can be detected by this algorithm. So this is the result and discussion part. So how we inserted the cycle slip in the real data is basically shown over this figure. So here there are two different color lines. One is blue for bold line, that is basically for L5 frequency, original carrier phase. But when we synthetically included the cycle slips, then it is dot line, the dashed line, that is showing you that at these instants, basically the carrier phase is broken. Similarly for the S. So basically, we have to develop a algorithm that can detect these changes and also correct these changes, so that we can restore our carrier phase and use it in a positioning algorithm for getting accurate position. Basically, it is the signal statistics and threshold determination. So 5GF, it is geometry-free combination is formed by taking the difference of two different carrier phase measurements of different frequencies. This phi L5 is for L5 frequency. This is for S1 frequency. When we put the values, then we subtract, then we get only the ionosphere term, ambiguity term, and noise
Manish,
parameter. Yes.
yeah, Manish, I think your time is up. What I would like to ask is, you were talking about monitoring the satellites, right? So any particular satellites or all the satellites are you looking at?
Yes, ma'am. In the case of Indian navigation system, we have a total 7 satellite constellations, out of which only 4 are working right now. So in the case of positioning, we are on minimal reception of 4 satellites, because only 4 are working and we are receiving 4 satellite data and working on 4 satellite data.
Okay. Thank you. It was a good presentation and nice, interesting work. Thank you.
Thank you, ma'am. Thank you, ma'am.
Before moving to the next presentation, I would like to inform you that respective presenters, as we are running short on time, we are kindly request everyone to limit their presentation to 10 minutes. Your cooperation will be highly appreciated. So next we have Karthike, paper titled Traits, a temporal and role-based anomaly detection system for insider threats to relational database.
Yes, sir.
You may please begin with your presentation.
Yes, sure, sir. Is it visible, sir?
Yes, it is.
Yes, good evening, respected panel members. So, myself Karthik. So, my paper title is TRATS, a temporal and role-based anomaly detection system for insider threats. So, my paper ID is 1192. So coming to the agenda of this presentation, so first one I start with the introduction to insider threats and then abstract, related work, motivation, threats architecture and the performance evaluation and finally compare with analysis with the baseline models. Okay, the first one, introduction to insider threats. So before going to discuss about the insider threat detection, first of all, what is an insider threat? An insider threat is a type of cyber attack originating from an individual who works for an organization. So here the basically the insider threat means where when an attack happens from the external, it is very easy to find when compared with the insider threats because the employer within the organization, if he do some malicious activity, then it is very difficult to find. So from the past, so according to the 2023 cost of insider risk global report, so an organization takes to respond to a security incident, it more expensive it becomes if an organization takes more time to respond to the event. So with insider threats over 91 days to detect costing an average of 18.33 million per year. And another incident, according to Verizon's 2023 data breach investigation report, hello, 89%, 89% of all cases involving privilege misuse are driven by financial motives. So coming to the abstract, so insider misuse of resources poses a serious threat to the enterprises. So in the existing approaches, so they try to solve the problem by considering the normal behavior of applications and they will find in terms of the data items accessed and the size of the result set and the access frequencies. In our proposed work, we developed a system, temporal and role-based anomaly detection system called a TRATS that considers both the roles played by the insiders and temporal data access frequencies to figure out the abnormalities. So to overcome the limitations of the role, we also consider the user level tracking. And finally, we designed the TRATS system which validate the correctness. And coming to the related work, these are the papers referred in the paper. So 2019 Asma Salam, and we listed some research gaps here. And coming to the motivation to tracks, so we observed that even in role-based access to the database, because in an existing paper, they consider the role-based access to the database, but for each distinct role, the data access behaviors change according to the specific time slots in a day. What it means? It means, for example, a user with, for example, an admin can have some access, but if a normal user cannot have an access to HR table or other financial tables or some specific account tables. So here we propose the TRAT system, an anomaly detection system which considers the temporal behavior of an individual roles to make anomaly detection more precise and active and effective. And coming to the TRATS architecture, here the TRATS architecture basically the first thing is the database logs. Here we generated the database logs from the from the OLTP workbench. Then here we created from the database logs, we generated the role profile. The first module is role profile building module. Here in the role profile building module, so we based on the past historical database queries. So here we generated the query signatures. So in the next slide, we will see what is a query signature format, how we generated the query signature. And then based on the query signatures, we computed the threshold value. So then when a new query issued by the user, so we are finding in the anomaly detection module, when a new query is issued, we generated the query signature and then that query signature is matching with the past logs of query signature. If this query, a new query which is issued now, if it matches with the existed query from the past logs, then we can go for threshold comparison. If the threshold exceeds the comparison above the threshold, then we can send it to a quarantine module. So here quarantine module, basically what it will do is it will check whether the query is really anomalous or not. If a query is not anomalous, then if the query is not matched with the query signature from the role profile, then automatically it's sent to the quarantine log. In the quarantine module, what we will do is we will validate the queries based on some certain conditions. So and finally, if a query is valid, it will go for database execution. And if the query is anomalous, then simply we will discard it. And the other advantage of this model is here we are dynamically finding the behavior of the role-based users. So if the query is anomalous, then we will discard it. But if the query is non-anomalous, then we will execute the query and again we will send it to the database for the next time threshold comparison. Coming to the data set, here the data set is used for experiments consisting of 90-day period. It includes 22 user sessions and 10,000 queries, so which is available in the OLTP benchmark data set. And coming to the role profile building module. In the role profile building module, we are creating the role profiles. The format for the role profiles is the type of the command, whether the command is select command or delete or drop or insert command. And the second role profile in the second parameter is the table ID. So 24576 is the table ID. And then the last thing is the attributes accessed from the tables. Here from this table, we are accessing the employee ID, employee name, employee age, and the account number. So we are taking some attributes 0, 1, 3, 4, the attribute IDs. And coming to the sample role profile for admin role, here for sample role profile, we are creating the role profiles. For example, there are different roles like admin, manager, and user. For each role, we are finding the query signature and its time slot. Here we are taking the time slots because the user role behaviors change according to the time also. So here we are considering the time slots in what time a particular role like admin how he behaves. And if a query is issued by some particular user in weekend, it is suspicious because as per the cert statistics, if the query is issued in the weekends or weekends are out of business hours, it will be suspicious. So here we are finding for each time slot in a weekend or weekdays, we are finding the threshold of it. And finally, in the quarantine
You
module,
have 1 minute to conclude your presentation.
okay, sure, sir. So here in the final quarantine module, here we are finding the formula quarantine factor equal to number of days occurred by 30. For example, if a query is occurred more than the number of times, then we will find the score of quarantine factor QF, and then based on that, we will validate it whether if it is above the cutoff, we will make it decision is valid. Otherwise, it is an anomalous query so that it will be discarded from and it will not be added. And finally, the performance evaluation gives the TRATs about 10 to 12% delay in query response time, and while CPU overhead stays below 4%. This confirms that our TRATs can continuously monitor the database activity with negligible impact on normal operations. And finally, coming to the comparative analysis with baseline models. So here in our TRATs proposed model, we have role-aware detection, time slot-based profiling, and adaptive thresholds, and query signature matching. This makes the model gives a better results. And coming to the conclusion, so the existing insider compared with the existing system. So here we are providing the basic features of rule aware detection, time slot based, and thresholding and signature matching. And these are the references. And thank you, sir. Thank you, ma'am.
Thank you for your presentation. Ma'am, any question?
Yeah. Karthik, it was
Yes.
a good presentation. And then any applications that you are looking at and working on, or is it insider threat for any application? Is it okay?
No, ma'am. Here actually we are not applied on any particular application, but this insider threat detection will be this model what we developed will be applicable for any application. It will be helpful for any application. The commonly it will give the same performance.
Okay. Thank you.
Thank you, ma'am. Thank you very much.
So next we have Sai Dipti, paper title Transforming Medical Education, Integrating Artificial Intelligence for Adaptive Learning and Clinical Excellence.
Is my audio
Yes, you
good?
are audible. Yes, yes.
Okay. Um, Good afternoon, respected chairperson and honorable panel members and all my participants. I'm Saidipti Gumalla, a PG student from SRM Institute of Science and Technology. The title of my work is Transforming Medical Education, Integrating Artificial Intelligence for Adaptive Learning and Clinical Excellence. This research examines how artificial intelligence can be meaningfully integrated into medical education based on real data collected from students and how it can support adaptive learning and clinical skill development. Okay. Artificial intelligence is growing rapidly in both education and healthcare. In healthcare, AI assists in diagnosis, medical imaging, and treatment planning. In education, it supports adaptive and personalized learnings. Medical education today requires modernization because traditional techniques alone can't meet current clinical demands. Students are already using digital tools extensively, but there are gaps in institutional methods. This study focuses on how understanding how AI can bring these gaps. AI is actively transforming diagnosis and training methods. Academic institutes are gradually adopting AI, and medical students are independently exploring AI tools. However, there is no structured AI curriculums in medical education. Since AI will be essential for future doctors, this lack of structures create an important education challenges. The study identified several key points. First, AI awareness among students is limited and inconsistent. Secondly, accessing to AI-based resources varies widely across institutes. Thirdly, there is no standardized AI training, making integration into coursework difficult. Therefore, there is a strong need for empirical insights into AI adaptation. Existing evidence shows that AI supports diagnosis, simulation-based learning, and personalized education. Also, AI improves student engagement and enhances clinical decision-making accuracies. This benefits indicates that AI can significantly strengthen medical training when implemented properly. Literature shows that AI has a high potential in medical training. However, ethical challenges, resource limitation, and lack of faculty training restricts adoption. Students shows interest in AI, but proper guidance and infrastructure are essential. Prior studies highlights a strong potential for AI, but empathize ethical concerns and resource requirement. Faculty readiness and critical and training plays a major role in effective integration. Despite a growing interest, the literature has clear gaps. Most studies are theoretical or involves a small sample sizes and using AI different models
Can you go
on
to
those data
methodology?
sets.
Sorry, Saidipti.
Ma'am,
Can you go to the methodology methods that you used and results?
uh, I mean after gaps I will go, ma'am.
No, that's okay because gaps and your literature was something similar, literature survey shouldn't be like that. Nonetheless, I said that's why I asked.
Okay, ma'am. Okay. The um, my methodology, I have used a study-based, using a survey-based descriptive methodology here, ma'am. It includes one-on-one participants and 16 questions instruments, descriptive statistical analysis while using to intercept the results. The survey consists of multiple choices and linkage scales. It covers demography, like a comparison between what kind of students have given their responses, AI awareness, and what sort of problems they are facing with this. Um, the questionnaire was pilot tested for clarity. Data was collected using Google Forms. This ensures a sufficient responses and data reliability. Majority of the responses were from students, particularly belongs to different academic years and varying levels of AI exposure. The demography describes was balanced in terms of gender and academic backgrounds. This diversity helps like capturing a wide range of perception. Research shows that 89.1% of students are using AI tools like ChatGPT and others, which are most commonly used. Students perceive AI as beneficial and essential for learning. AI is mainly used for research, clinical, reasoning, simulation, diagnosis, and assessments. This area also highlights AI role in analysis and practical learning. Major barriers includes limited infrastructures, lack of training, privacy concerns, and institutional consistency. These barriers slows down effective AI integration, ma'am. Students use AI mainly for research enhancement, clinical reasoning, and all others. However, only 45.5% of students have received a formal AI training. Students who received training shows higher confidence in using AI tools. Most students express the need for structured AI modules, preferring workshops and hands-on practices. This clearly highlights a significant training gap. Readiness varies across academic years. Overall, proficiency was moderate, but students shows a positive attitude towards AI. Familiarity and training increase satisfaction and confidence. Usage of frequency strongly influenced learning outcomes. In conclusion, AI usage among medical students is steadily increasing. However, barriers such as infrastructures and training slow adaptation. Students shows a strong interest in learning AI, highlighting the need for organization and structured implementations. Proper institutional planning can significantly improve AI-based learning outcomes. In future, medical education can benefit from VR and AR integrations, personalized AI-based learning systems, and structured AI ethical trainings. Institutes should also develop a clear AI policies and invest in faculty development. With these steps, AI can truly transform medical education. Thank you for your time and attention. If you have any questions.
Yeah.
Thank you for the presentation. Ma'am, do you have any
Yeah.
question?
Yeah, you talked about AI tools in medical education. So what tools are you talking about here?
Ma'am, here we can divide AI tools into two different types, ma'am. One is like for complete theoretical one for students' studies, examination, like completely personalized one. And another here is for clinical experiences, ma'am. We are having a different kinds of AI modules we can use for diagnosis and all, which is very effective. But most of the medical students doesn't know how to utilize them, or how they don't even understand anything about AI, which is really typical here.
Okay. Okay, I also want to understand what do you mean by limitation when you said infrastructure limitation?
Ma'am, mostly here we can see that students are using like ChatGPT and other kinds of things for their own questions and any queries if they
No,
are
but
having.
ChatGPT,
But
but ChatGPT does not require any infrastructure, right?
No, ma'am. I'm talking about like we have seen a small case like for COVID example. If we take, we can see by analyzing the data, we can see whether the patient has a COVID or not
No,
according to the symptoms.
no,
But
I
this
think you didn't
kind of
get what I'm
modules we
saying.
have already trained one, but
No,
the
that's what I'm
same modules,
saying.
I mean,
Nahi, I'm
these
talking
medical
about
institutes can utilize them and guide the medical students
infrastructure
towards
is not
AI
a
tools.
barrier. Girl, listen to me. Infrastructure is not a barrier to use AI tools, okay?
Oh,
Yeah. Thank you.
oh, thank you.
Okay. The last presenter, Sangeeta. Paper titled Machine Learning Classifiers for Pregnancy Risk Prediction with Identification of Optimal Algorithm Type and Key Maternal Characteristic using Maternal and Obstetric Database.
Am I audible? Yes. Am I audible? Hello.
Sangeeta, are you there?
Yes, I'm audible.
Your voice is too low.
Okay, just a minute.
Ashwat, do you wind up? What is that?
Just wait, ma'am. Hello,
Yes, yes.
am I audible now?
Yes, you are audible.
Uh, my screen is visible.
Yes, you can start the presentation.
Okay. So myself, Sangeeta Vasme, I'm associate professor, and my colleague, Dr. Parminder Kaur, she is a professor of MGM University, Chhatrapati Sambhajinagar, Maharashtra, India. Just a minute, what happened? Okay. So,
Shashwat, I'm unable to see the PPTs.
Same here, ma'am. Sangeeta, can you please share the PPT?
yeah, just now visible.
Only your share. Yes, now it is visible.
Okay, fine.
Yes, you can start.
Okay. So pregnancy is a critical period that requires continuous monitoring to ensure the health and safety of both mother and child. Hypertensive disorder during pregnancy is occur around 10% of pregnant women all over the world. In Africa and Asia, nearly 1/10 of all maternal deaths are associated with this hypertension, and it is a life-threatening for both mother and fetus, which in turn increasing the mortality and morbidity, and is also affect the organs like kidney, liver, brain, and may slow down the growth. Despite there is a advancement in healthcare, but maternal mortality remain unacceptable high. And according to the global health indicators, the causes of maternal death are well understood and are highly preventable and treatable. In 2023, their estimation of 700 women dies because of this preventable causes. And between 2000 and 2023, this mortality rate is going to be decreased, but 92% of maternal death in 2023 is occur in a low and middle income countries. And according to the WHO, they are estimated 295,000 women die during this pregnancy and childbirth related causes. So here, the need is to reach to each individuals that is at high risk, including the
Shashwat,
women in low income
Shashwat,
household,
the
slum.
slides are not changing.
Yes, ma'am. Miss Sangeeta, your slide was not changing.
What happened? I'm not getting what happened.
Just
Stop.
click on the resume slideshow, what I can see on the screen. Can you see resume slideshow?
I see here your screen sharing is pause and
Yeah, that's what
stop
I'm
share.
saying. There is a resume slideshow that is visible to us. You can unshare and share again if things are not working.
What happened? Just see. Okay. Share. Now. Now visible.
Yes. Now it is visible. Now it's okay.
Okay. So here we need to reach to each individual who is at high risk, individual women in the low income household, slum, rural, urban, adults and mother in order to meet worldwide aim of improving maternal health and saving the women's lives. From the existing studies, they are highlighting the strong potential machine learning techniques related with the prediction of maternal and pregnancy related health risks. Mostly assemble based machine learning algorithm they are using, which included random forest, gradient boosting, edge boost, along with the decision tree and logistic regression. They are consistently showing superior performance across multiple data sets. And here the data set which are used is a supervised clinical feature data set which include maternal age, blood pressure, glucose level, body temperature, heart rate, and medical history. And here from the literature study, I just find out some maternal risk parameter in involvement which is contributed to the risks of the pregnancy during the risks of the pregnancy. Example, adolescent and old age, mother age, then a BMI is very less than 140 centimeter, obesity, anemic. Then there is what limited antenatal care utilization, gravida, parity issues, nulliparity, low parity, and previous adverse birth outcomes, then pre-existing diabetes, chronic kidney diseases, hypertension, blood pressure disorder, smoking, tobacco, alcohol consumption, then poor economic condition, lack of education, limited access to healthcare. These are the major contributing factors for this prediction of the pregnancy risks, which we are getting from the literature studies. So the here the objective is what so many work is done in this area, but not a particular not particular sequence of parameter they are able to find out to for prediction of pregnancy risks. And so I look after that. So I just so here are the objective is two objectives. One is what to find out optimal algorithm type and key maternal characteristics using maternal and obstetrics dataset. So in my proposed work, I'm going to use a machine learning classifier like logistic regression, then KNN, SVM, NB neural model as MLP model, then a random forest, gradient boosting, edge boost, light boost, and CAD boost. Here I'm going to compare three data set, uh, that I'm going to use over here. And after that, for a to find out the contribution of maternal characteristics, key maternal characteristics for pregnancy prediction. For that, I'm going to use a feature importance analysis. And model performances are evaluated using accuracy, precision, recall, and F1 score. So these are three data set. First data set A, which is having 202 record, which is taken from Stanford, and these are 46.53% is regarding high risk and 53.46 regarding low risk patients. Data set B is taken from the Kaggle and total record is 282. There are 6 independent features and 44.68% belonging to high risk and 55.31% belonging to low risk. A data set C is taken from the Mandela and it is having 1148 total record. 11 are the independent features and 40.33% and belonging to high risk and 59.67% belonging to low risk records. And this is what statistical analysis. In this statistical analysis regarding the first data set, which where we only consider maternal obstetric history, which include age, gravida, parity, and BMI. So here the most contributing factor features which is belonging to age group 20 to 35, it is 66.94. And then multigravida patient 52.12%. Obsessed BMI patient is 46.80%, and 30.10% is nulliparous patient contributions is over there. This is regarding to the data set 1. Related to data set 2, which only included maternal characteristics like age, systolic blood pressure, diastolic blood pressure, blood sugar level, heart rate. And here more contributing age group for this is 20 to 35, which is 40.47%. Systolic blood pressure, which is 130 mm, is 50.79%. Diastolic blood pressure, which is 80 mm, it is 63.49%. Blood sugar level greater than 7, which is contributed 85.71%, and heart rate is 100%. Is contributed over there. And third data set is regarding both the characteristics are involved, maternal also and obstetric history also. Here 11 parameters are going to be used: age, systolic blood pressure, diastolic, sugar level, heart rate, BMI, previous complication, pre-existing diabetes, gestational diabetes, and mental health. And here also 46.87% is involved contribution of obesity. Then 43.20% is a high risk patient of involving past history complications, and 67.39% is involvement those who having a history of pre-existing diabetes. Then 29.59% record of patients are involved who are having a gestational diabetes. Then 70.19% of women which are involved in having the mental health issues. And these are the correlation matrix which I shown related with the data set 1, data set A, data set B, and data set C also. In this, when I going to use
Sangeeta,
all
you
the
have 1 minute to conclude your presentation.
Right. For data set for data set A, from the for implementing all the machine learning algorithm, light GBM is giving nice performances, that is 66%, and simultaneously for same method there is what feature importance matrix. First database 2, two methods are giving the nice, excellent accuracy. That is random forest, light GBM, 91%, 91%, and the same feature importance matrix for same method is mentioned over here. And in third data set, GBM is giving 99% of accuracy, and feature importance matrix is also provided over here. And at the end, I'm going to combine all the three data set, and collectively I find out here feature importance of for all the features from the three data set. And from that, I concluded that uh, when I go for feature importance things, so blood sugar is a contributed 30% contribution for the pregnancy detection. BMI, gravida, gestational diabetes, they are contributed 20 to 30%. Age, systolic blood pressure, which is contributed 10 to 20%, and remaining is below 10%. So these are the contributing percentage of contributing factors for the prediction of preeclampsia. Thank you so much. And these are the references.
Thank you for the presentation. Ma'am, do you have any question?
Yeah, this studies what you have shown is on the data set that you have taken, right? Not on the actual data that is available with any gynecologist.
That is not enough. It is with me, but that is not enough. So I just I added many more things I try to collect many more things in a collected data, but that is not enough. It is a record is not sufficient. It is only 50 records I will able to collect. So that's
But
why
if
I'm
you
going to.
approach a bigger hospital through your university where you're working, and they give you permission for the data, but there is a lot of procedures for that to acquire the patient data.
Right. So I go for the government medical college because there are varieties of patient over there. And here the thing is what there is not a particular pattern for the prediction of maternal risk factor. So many things parameter need to be added, and that so it is time consuming and need more study. So I just go for the previous data set and try to compare which are the more influencing parameters for this prediction.
Okay. Yeah. Thank you.
Thank you, ma'am.
Yeah.
Okay, the next presenter was Elishta, paper titled Modeling Autonomous Border Surveillance System Integrating Movement Model and Multi-Agent Communication.
Hello.
You can present your screen.
Yes. I hope you seeing my screen, okay?
Yes, it is visible. You can start.
One second. First, thank you for the opportunity to present my article. My name is Elica Benciova, PhD student in Sofia University. Today, I will present our work on modeling an autonomous border surveillance system, which integrates movement dimensionality with multi-robot communication. The goal of this work is not to propose a single robot or a specific hardware platform, but a structured behavior model that scales from a simple one-day patrolling to heterogeneous multi-robot systems. Okay. Any robot that operates at least partially autonomously needs a behavior selection model. This behavior defines the relationship between the available environmental information, sensor input, and actions. The behavior is divided into the several parts: locomotion and navigation, object detection, obstacle and collision avoidance, safe wandering, energy management, and task planning. And so some of the parameters of this behavior are movement models and mission definition. And finally, communication shapes the behavior characteristic based on the available information. Okay. The movement model of the mobile robot shapes its behavior characteristic as locomotion strategies directly influences core capabilities such as autonomous navigation. These behaviors are shaped by the robot's operational dimensionality, 1D linear, 2D planar, and 3D spatial motion frames. By restricting or expanding the robot's degrees of freedom, the dimensionality of motion dictates its locomotion strategies, obstacle avoidance mechanisms, and goal-achieving methods, ultimately determining its role in real-world applications. The choice of motion module depends on the environment complexity and the task. While 1D systems dominates in industrial automation, 3D robots unlock unparalleled exploratory potential. Future advances in hybrid models, such as 2.5 in route terrain robots, may further blur these boundaries, but the basic principles of dimensionality will remain central to robot design and functionality. Actually, choosing the simplest efficient motion model is often the most robust engineering decision. Missions, the high-level objective assigned to the robot dictates how its internal subsystems are dynamically synchronized. For example, a delivery robot and surveillance drone both rely on obstacle avoidance, but their missions diverse in how they prioritize actions. The first optimize speed and route efficiency, while the second emphasize persistent environment coverage. In the graph, we see a classification of mobile robot missions by Claudio Menghi, which specialize in commercial human-sized service robots. In full definition of the robot behavior can include one or more of these defined missions. For example, surveillance robot in a building during the off hours can include order patrolling and avoidance, where avoidance is guaranteed that the robot will avoid obstacles. Additionally, we can add triggers, which allows it to set the condition for starting and stopping the patrolling task. Depending on the robot's application, additional behavioral requirements may arise, like arm manipulation, speech, face and position recognition, speech generation. In all cases, the robot must efficiently control these devices while emphasizing energy consumption. Behavior, we model robot behavior as a set of interacting models rather than a monolithic algorithm. These models fall into three groups: sensing and execution, planning and coordination, and safety critical behavior. This modular structure makes the system extendable and reusable across different robot platforms. In the next few slides, we will briefly review these characteristics for greater clarity in definition our model. First is locomotion, is the most basic capability. Wheels, legs, or propellers are directly affect the energy usage and terrain accessibility. Navigation is split into the global and local components. Global navigation determines where the robot should go using algorithms like A*. Local navigation handles real-time obstacle avoidance, often using SLAM and reactive planners. This separation allows the robot to pursue long-term goals while safety reacting to local changes. Object detection is central to surveillance. It supports other components like navigation, collision avoidance, and intrusion penetration detection. Obstacle and collision avoidance combine perception and decision making. The most optimal goal is to prevent collision before they even occur, and the most universal rule is when avoidance is not possible, the safest action is often to stop and wait. Safe wandering is a special case. It addresses situations where the robot loses localization, for example, after a collision or sensor failure. In such cases, exploratory behavior allows the robot to recover its position and to resume its mission. Task planning connects low-level behaviors to high-level mission goals. Algorithms
You
like
have 1 minute to conclude your presentation.
okay. It prioritizes tasks while safe wandering, charging, and others. Energy management is tightly integrated. Robot continues monitor battery levels and coordinate charging without leaving the perimeter unprotected. This is when we need multiple autonomous agents, the coordination share information and react to events like penetrations or low battery without relying on a fragile central control. This motivates a model that combines movement dimensionality, behavior definition, and multi-robot communication in one coherent framework. Our border surveillance operate primarily in 1D, but when it's necessary in limited situations, it can operate in 2D motion. So we describe here our motion model 1.5D, mostly linear movement with constrained planar deviation when necessary. Finally, the communication is important as motion when we have a multi-robot system. So it's divided into explicit communication between robots and implicit with sensing the environment. Basically, our decision is to use hybrid communication between robots to get the best parts of centralized and decentralized. Simulation future work focuses on simulation results, hardware constraint, and extending the model to the heterogeneous robot teams. Metrics include like detection latency, coverage, and communication overhead. At the moment, we have started the best test simulation that proved the validity of the defined minimum characteristic of the model. This provides a control way to validate design decisions before hardware deployment. And thank you.
Thank you for the presentation.
Can you hear me?
Yeah. Thank you for the presentation.
Thank you.
I sincerely thanks our author for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenter would be getting their digital certificate through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. Now, I also thanks our session chair, Dr. Umar Patel for chairing this session. A token of appreciation to the chair on behalf of our team ICTCS 2025, a Global Knowledge Research Foundation and partners. Thank you for their presence, ma'am. Now, I kindly request you all to switch on your camera for a quick snapshot of a virtual conference. Kindly switch on your cameras. Okay. Thank you. Have a nice day. Stay safe.